when you are solving by factoring, first you have to have the equation equal to 0. If you are intending to factor and solve, you need to have equals 0 before you get started. So in number 1, it already says equals 0, so we can factor the left side. Always try to start with greatest common factor. What do the 3 terms have in common? They have x in common. X to the third divided by x is x squared. Negative x squared divided by x is negative x. Negative 12x divided by x is negative 12. And we still have the equals 0 on the right. Okay, we need to factor this trinomial. So we're looking for 2 numbers that multiply to give us negative 12 and add up to negative 1. Anyone have it?
3 and negative 4.
3, negative 4. So that part factors into x plus 3, x minus 4. We still have the x in front, and we have equals 0 at the end. That is fully factored. Now all we have to do is solve it. There are 3 pieces here. I'm going to call them the yellow piece, the green piece, and the blue piece. The green piece and the blue piece, that's kind of what we're used to from last semester. If x plus 3 needs to be 0, what number plus 3 would give us 0?
Negative 3.
Negative 3. So our solution for the green piece is negative 3. How about our solution for the blue piece?
Positive 4.
Positive 4, because 4 minus 4 would give us 0. For the yellow piece, 0.
Oh, so smart.
Okay? If the yellow piece is 0, 0 times anything is 0. If the green piece equals 0, it'll make the whole thing 0. If the blue piece equals 0, the whole thing is 0. So your 3 solutions come from putting each of those equal to 0 and figuring out what x needs to be. A huge hint, if you look at the original problem, look at the largest exponent. The largest exponent was 3. Notice we ended up with 3 solutions. Your largest exponent will tell you how many solutions you can have in that problem. So if your largest exponent is a 4 and you somehow end up with 6 solutions, you did something massively wrong, because it's not possible to have 6 solutions if your largest exponent is 4. Okay, let's look at number 2. Anyone want to take a guess what we should do first on number 2? Subtract 28 on both sides. So we are going to have 3x to the third plus 7x squared minus 12x minus 28 equals 0.
Oh boy.
Oh boy. All right, I see a 3 in front, so I'm going to check. Can I factor a 3 out of all of those?
No.
No. I see a bunch of x's. Can I factor any x's out of all of them?
No.
No, because the last term doesn't have an x. So we have 4 terms. We can't factor anything out of those 4 terms. What do? We don't cry because we love factoring. So we definitely don't cry. Grouping.
Yeah.
Oh, yeah.
Split it down the middle. Yeah. Cry. You guys crack me up. Okay, the first group. 3 and 7 don't have anything in common, but they both have x squared. Yeah. 3x to the third divided by x squared would be 3x. 7x squared, take that x squared out, we'd have 7. What about negative 12x and negative 28?
4.
Negative 4. 3x plus 7. So our factored form is x squared minus 4, 3x plus 7. Are we done?
No.
No. That x squared minus 4 we can factor into x plus 2, x minus 2. We still have the 3x plus 7, and the whole thing is still equal to 0. Wow. Okay, I really like colors because I think it just makes it easier to think about. So I've got my yellow piece, my green piece, and my blue piece. Okay, yellow. What's the solution? X equals negative 2. Green, what's the solution? Positive 2. Blue, what's the solution? Okay, some of you already know the pattern. The answer is negative 7/3. If you're thinking, how in the world did you get that without showing any work? I will show you. But what you need to do, if you need to show work, you take the 3x plus 7 and put it equal to 0. Subtract the 7 on both sides to get 3x equals negative 7, and then divide both sides by 3. That's how you get the negative 7/3. Now, how did people get that without showing any work? The shortcut is take the opposite of the number. So since it says plus 7, take negative 7, divide it by the number in front of the x. Negative 7 divided by 3. All right. I think you can probably try number 3 on your own. So pause the video if you're watching the video. Give number 3 a try on your own. If you factored this correctly, you should end up with x squared minus 9 and x plus 2. X squared minus 9 factors further into x plus 3, x minus 3, and we still have the x plus 2. So our solutions are negative 3, positive 3, and negative 2. And you can either write it out, x equals negative 3, x equals 3, x equals negative 2, or you can just list them. Technically, I should make you list them in numerical order from smallest to largest, but I mean, who's got time for that? Seriously. So some of you are very OCD about your work, so I'm sure that you will do that, but you don't have to. All right, number 4. What do we need to do first in number 4? Okay, subtract. So we have 5w cubed minus 50w equals 0. What?
You can get out the 5 and a W.
A 5 and a w, leaving us with w squared minus 10. And I heard something truly amazing last hour. I had a student bring up a problem and say, I'm stuck. It says w squared minus, so I know I'm not done factoring, but I can't figure out how to factor this anymore. So apparently I have drilled it into your head that x squared minus means that you're probably not done. Sometimes you are done.
Oh, that's confusing.
Is 10 a perfect square?
No.
If you try to take the square root of 10, you get a crazy decimal. So you can't use difference of two squares here because 10 isn't a square. So I'm happy with that comment from the student because it means I've gotten through to you that when you see x squared minus, you're going to think, oh crap, I might not be done. I might need to do more. When do you not do more? When it's not a perfect square. So in this one, we are done. There's nothing else we can do to factor. So now we have to think about solving. Okay, so first of all, the yellow piece. What is our solution for the yellow piece? 0. Even if you have something like 5w to the 7th, and that's the only thing that you have there, your solution would be 0. If all you have is a monomial term, that w would have to be 0 to make that thing equal 0. All right, now for the green piece. We take w squared minus 10 and put it equal to 0. We would add 10 to both sides to get w squared equals 10. How do you undo a square? Square root. What do you have to put in front of a square root? a plus or minus. So W equals plus or minus the square root of 10. Oops, I used green, not blue. Now, if you're thinking, wait a minute, there's supposed to be 3 solutions, because some of you really picked up on that. The largest exponent is going to be the number of solutions. There are 3 solutions here. The 3 solutions are 0, square root of 10, and negative square root of 10. So if on an online assignment you had to enter 3 solutions, you would split them up in that way. Okay, I don't think we need to fully do number 5. I just want to remind you about the type of factoring problems we did yesterday. Do these 3 terms have anything in common? No. That is honestly unfortunate. Because what do we need to do with that 9 when there's a number in front? What's 9 times 4? We need to find 2 numbers that multiply to give us 36 and add up to negative 12. Thankfully, I think that number is pretty easy to find. Negative 6 and negative 6. When there's a number in front of that first term of the trinomial, you have to split this into 4 terms. You've got 9x to the 4th. We're taking this term and splitting it using the numbers that we found. So negative 6x squared, negative 6x squared plus 4. Then we factor by grouping. The first 2 have 3x squared in common. The second group has negative 2 in common. So this looks kind of funny, but your factored form is 3x squared minus 2 times 3x squared minus 2. You could just make that squared. But when it comes to your solutions, you have to do 3x squared minus 2 equals 0 and solve that equation. So you'd add 2 to both sides to get 3x squared equals 2. Divide both sides by 3. And then take the square root. So x is the positive or negative square root of 2/3, which then you'd have to rationalize the denominator, and it would be big and ugly, and I'm probably not going to give you that on an assignment or a test or a quiz or anything like that. I just wanted to show you that is what is going on here. And there actually are 4 solutions. It's just you've got positive square root of 2/3, negative square root of 2/3, and then because that is repeated again, those would be solutions again. So it's like there's repeated solutions in there, which is kind of weird. Okay, that's all. Your assignment is online. It's called 4.5 Day 1 when you go in online to find it. And if you absolutely don't want to do this online or can't do this online, it is on page 194, and it's numbers 3 through 6 and 8 through 10.